This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. This is episode 67. I'm your co-host, Dan Blewett. On today's episode, we're going to talk about some disinformation, maybe just a good meme, but we'll talk about the continued trend of the internet sometimes ruining everything. We'll also chat about a really scary incident with a wind turbine tech recently out of Iowa, fell down the inside of a blade, rescue effort, and was successful. He was mostly unharmed, but still an interesting thing with some interesting implications. We'll talk about some work GE is doing, their TI project, trying to get a little more aerodynamic efficiency out of their offshore blades, and a really interesting cast-in-place concrete tower concept. So before I kick it to my co-host Alan Hall, just remember we've got Uptime Tech News is our new newsletter. You can sign up in the description of this podcast below, whether you're on YouTube, iTunes, Spotify, wherever. And that's just our monthly, that's our weekly update where we're going to send you the new podcast, some great news from around the web, new tech, all the stuff that we're keeping you up to date on. So if you enjoy the show, you'll definitely enjoy just getting our weekly Uptime Tech News update. So sign up for that in the show notes of this podcast. So Alan, how you doing, sir? Let's talk about some disinformation. So first, on Facebook, this thing just started going around. It's like, haha, look at this wind turbine that melted in the Texas heat, and they showed one of those photos, which are crazy photos of. So it sounded like this was a turbine damaged by a storm, where basically all three blades were damaged and essentially just wilted. Did you? So, what were your thoughts on this photo in general? It's a pretty dramatic photo of this whole wind turbine just wilted.
It is. The early indications about the photo were that it was a lightning strike. That was the first thing I saw, and then the heat. The discussion about when it got so hot in Texas that the blades just melted.
Yeah, just wilted like a flower.
Yeah, so that was funny. And then the latest was maybe his wind speeds, but none of the other wind turbines in that area had that same fault. So it makes you kind of feel like lightning strike broke one of the blades, and then it cascaded into vibration, which broke other ones, and everything started. Looks like it's all sagging. So that's going to be an interesting repair, don't you think? Like, how are you going to do that? Are you just going to cut down the whole structure and start over, or what? Because working around big, massive piece of broken blade still hanging from the hub is not easy, and it's got to be a safety issue, I'm sure. But on the meme front, isn't it interesting how fast that went around? Like, I must have saw that 50 times in a day. That same image or a discussion about it. It's like, bang! Everybody in the world, at least in the U.S., saw this thing almost instantaneously. It was crazy.
Yeah, and that's what's so baffling about the internet, is that this could become like an actual, like I said, I looked up the Facebook post. I looked at a lot of the comments. Most of the comments were like, ha ha ha, yeah, right. It was 500 degrees in Texas, ha ha ha. Like, most of the people understood that this was not an actual melting, but it's crazy that misinformation can spread so far so fast. And just be weaponized if people want it to be, right? Just to
they got fact-checked.
Push whichever agenda. Right. Yeah, and that's the thing. I mean, do you feel like the fact check almost gives it more? I feel like a lot of times you just need to keep this stuff out of the news cycle entirely.
Yeah.
Like, the fact that it was fact checked got more people to hear the the piece of misinformation itself. And it's just like, I've been thinking about some of the, to jump this into politics, not on either side, but just some people who have crazy theories, about election results or whatever in the news cycle. Like, if it's one of these debunked theories, why even post them back on the web, right? Like, Joe Schmo has some insane thing he says, but because it's posted on a bunch of major news outlets, it continues to go out there, and it continues to give this person credence. It's like, why even, like, let's just, if it's debunked and it's a nonsense opinion, let's just not put it in the news cycle. Yeah. Like, just don't write about it, and it'll go away, right?
There's two polar opposites that are happening right now in that space, which is fascinating, because I think this wind turbine incident falls right in the middle of that. The first is on the, I'll call the political left. On the political left right now in the United States, there's an effort via the YouTubes and the Twitters of the world to filter, right? And they're filtering certain things, particularly around COVID right now. And on the right, there's a lot of screaming about fake news, right? So you got one polar opposite, which is trying to filter the news, and you got the other side saying you're filtering the news. What happens in the middle of that? Because both ends are correct to some level. There's some truth, obviously, in any sort of claim. There's some truth to it, and then it kind of goes off to where it goes to. But the fact that you could put out such a picture and a little meme with it, that it would gain traction to the point that someone needed to fact check it, that it shows that there's such a distrust in media right now.
Yeah.
That no one believes anything. Even the fact check is going to get poo-pooed, right? Oh, it's just a big wind covering for themselves. I bet you I could find that comment on a Facebook post instantaneously, right? So it's a weird political news environment politically, but it's having implications into what I would term the scientific engineering community. Particularly in medicines right now, but it's also rolling into other engineering things, green energy also, where it's creating this weird, no one trusts anybody because you can't environment. And then this stuff pops up, and you're going to see this. You're going to see that wind turbine for the next 5 years on posts. I guarantee it. And maybe you're right, Dan. Maybe whoever fact checked it made the initial mistake. Not to fact check it would have been a better idea.
Moving on, this crazy story from Iowa. This wind turbine tech got stuck in a wind turbine blade. And of course, these are getting bigger and bigger. Obviously, this is onshore, so they're not nearly as big as some of the offshore ones, but these are still really big blades. But a worker for Mid-American, was stuck in this blade, and it was a pretty scary incident. He's okay, but what are your thoughts on this, Alan?
You don't hear about this happening very often. You would think it would happen more often, just because there's a big, massive hole where the blade is that you could stumble into, and it sounds like somebody just stumbled backwards into this thing. And luckily, obviously there's 3 people on site typically that are working together just for this reason. If somebody gets in trouble, you can have somebody call some help or pull them out. But they had to call emergency crews to help get this guy out of this wind turbine blade. And it happened at night, thank goodness, because obviously the wind tends to be a little bit slower at night, and it's cooler at night. Can you imagine doing this in the middle of the day?
The heat factor.
Oh, yeah. You could have really been in trouble fast inside of a fiberglass structure in Iowa in the end of June, where it can be 105 outside, and it was recently in the Midwest. So it would have been 120, 130. Yeah, you could have had more than just a physical a broken bone or anything. You could have died in that situation.
Just stuck in a little oven. Yeah, you're
overheated. You could definitely overheated. So I'm sure they were very thankful about that part of it. Now, I don't know if this is part of the ongoing effort on the Vestas side to swap out blades and do some repairs, or doing some repairs in the blades. It sounds like from the lightning protection side. It kind of smells like that Vestas had that issue with Mid-America lightning protection, and was going to make some retrofits from the sounds of it. So maybe they were making retrofits in the blade and stumbled. That wouldn't surprise me, because it sounded like the retrofits that were being made near the hub of the blade, not at the tips. Mm-hmm. So they're working down the hub and they make a misstep and loss of footing, and boom. Yeah. So we'll be more careful.
Well, and what I was wondering about, obviously, it's not like one of these slides where it's just going to be a smooth, the outside of the blade smooth, but the inside is certainly not smooth. And God, you just wonder if even if the blade was at an angle where it's not like a straight fall straight down, you're just sliding down it. You just wonder how many seams and bolts and, obviously there's lots of things inside the blade, like the down conductor.
Yeah.
You just wonder, you're sliding down the slide potentially and seeing little obstacles that you're going to hit at a high speed as you pick up speed. And that's
and they're
what
sharp.
Could also kill you. It's just really scary. Yeah. Paul Geip, who's a guest on our show, who's an expert in a lot of the things in safety, and he studied that over the years. He was talking about one of these old ladder designs in towers. They kind of got the moniker of gut rippers, which it was this ladder, instead of having obviously every ladder has the rungs, right, and then it has two things on the outside, right? So it makes that H shaped. But on these gut ripper ones, which is the term you use for it, is they have one column down the center, and then the rungs extend out, and there's nothing holding the edges of the rungs. So if you were to fall down that tower and snag your body on one of these rungs because each of the edges are exposed, that could
really hurt you,
rip you open as you're falling.
Sure.
Yeah, I mean, that could be the reason you die, and that's why those ladders, I think, have been phased out, because they realize that there's some gruesome things happening. So it's really lucky this guy was okay, didn't hit anything, because it could have gone a lot worse, I'm sure.
Oh, yeah. It could bleed out. If you ever play around fiberglass long enough in epoxies, you know how sharp those corners and edges can be. And getting cut, being stuck, bleeding, it could be bad fast. So, you got to give a hand out, some thanks out to the rescue crews, because this is kind of in the middle of nowhere, right? It's not near a big city. So you're dealing with local fire departments and local ambulance crews and safety people going out there and helping out. So it's a local effort, and you got to give them a hand, because they were ready for it. They were ready for it, and it seems like everybody came out okay, which is good.
So moving on, so the GE TI ADE turbine improvements for additional energy project, they're trying to develop, just some add-ons, whether they're vortex generators or whatever, onto the tips of blades, especially offshore, to just try to, suck a little more power out of them. Alan, to me, this seems like, vortex generators have been out for a long time. We've got a couple articles about them on our website. Our friend Nicholas Galdern from Power Curve was on the show talking about some of the well-known efficiency upgrades that they provide. Why this press release now in 2021? This seems like they're announcing a thing it almost feels like old news, but is it?
Well, that's a good question, because a lot of the add-on aerodynamic changes they have listed are definitely things we've known about for a long time. And is it really the add-on feature like a vortex generator, or is it more about where the vortex generator has been located on the blade, and maybe the shape of the blade a little bit in combination with some other add-ons that you start putting pieces together and the right symmetry comes in, and then you get this 1%, 2% improvement, which is what they're looking for. It's odd because, like you said, it's really known things, but I think realistically what appears to be happening is they must have CFD aerodynamic analysis of all of these things, and they must have probably some level of wind tunnel testing done. Seems like GE and LM have the wherewithal to do some wind tunnel testing. There seems like there's a correlation to the real world that they're missing. So they're trying to connect CFD to wind tunnel results to what actually happens on a turbine, must be a missing link in there somewhere, because they're applying so many different pieces aerodynamically. That's what you do if you're trying to box a problem, right? One of the ways to sort of box a problem is to put a bunch of variables in and see where the extremities are of this problem set. And that's what this sounds like, is like, oh, let's try a bunch of different things. Let's try to understand what we can do and what we can't do. And can we come back into a modeling environment and actually model it correctly, and then know that's going to be an improvement. That's what it feels like. But it's weird that they're actually going to make 12-meter long sections of blade with different fittings on them and different aerodynamic fixes, quote unquote fixes, to do that. And how are you going to monitor that? It's going to take you several weeks or months to get enough data to pull out the marginal improvement in performance, because you can't necessarily measure 1% in 24 hours, right? You need to let the turbine run for a while.
That's true.
So it's going to take months and months and months to do that. And then when do you call it quits? Like, this isn't working or this is working. Like, that's going to take them months of time to do that. It's a very interesting concept. And hopefully they push out some data. GE obviously made a big press release about it, because even I saw it. It was blasted everywhere. So they're looking for some PR on it. It's an interesting thing you wouldn't expect to see at this point.
Well, that was going to be my other question for you is, we've talked about the secrecy in the wind industry and how companies want to keep a lot of this stuff to close to the vest. This almost feels like one that I wonder why they're putting this out as a press release. Like, what do they gain by doing this?
Yeah.
When it seems like so many little things like this, like that they're testing, they don't want to be out in the public. You think this may be just a shift in overall, they're just trying to just get more out there and just be more in the news cycle because of how much wind energy is going to take off in the future? That might be good for them long term, right? That everyone's, oh, GE is always doing research, more, it's another gold star for when they're trying to, win development contracts. I don't know.
I think the offshore wind environment and wind economy in the United States is driving GE to do things, because GE is seen to be the winner before it even starts in terms of offshore wind in the U.S. And the way you give that impression is you're doing all these things that seem green, right? And so even if you know the answer, or a pretty good handle on the answer, putting out press releases, particularly in the United States, plays to the political aspect of this and getting states and localities to welcome you in. And GE being an American company, that's pretty easy to do already, but it doesn't hurt to keep pushing your credentials about how green of a company that you are, regardless of if it's, a major financial impact press release or just an engineering press release, which is kind of what this is. It does add to that resume of, hey, GE's a green company. Because if you said GE 20 years ago, green energy wouldn't have been in the top 100 things that you would relate them to. So I think GE as a company has to get over that hurdle of a lot of people in the Northeast think of GE as a big industrial company that made generators and locomotives and all kinds of refrigerators and all that kind of stuff. And now you're trying to refocus people into thinking about them as differently as a company. And that seems like what this, at least in part, what this is about.
Yeah, and of course their stock has rebounded quite a bit from last summer. Last summer it was in the $6 range, and now it's in, as of today, it's $13.42 a share. Of course, they're actually doing a 1-to-8 stock split. So if you own eight shares of GE at $13.42, for example, you'll get one share at, that would be like $104, something like that. So they're reading about some of that stuff recently. They just said this is where we feel like, I don't exactly know the ins and outs of it. I'm an amateur stock market. I don't know what I would call myself, but I have an awareness of some of the stocks I follow and some of the companies and some of the big ones in wind energy. But it's a great question, but they just said this is where we feel like our share price should be.
Okay.
So obviously no one loses any value, but it seems like they just they don't want to be a $13 company on paper. They'd rather be a $100 company, which I kind of understand. There's definitely a psychological effect there, right?
Yes, there is. When Tesla sits at
if your
400
stocks,
or whatever it is, you feel you're at 13. You kind of don't feel it, right?
Well, and you wonder if that attracts bigger investment money because, when you think about it, so like Shopify is a good example. Their stock's like 1,500 a share, something like that. Amazon stock is, in the 2,000s per share. And obviously they could divide it up and make it, Apple split their stock last summer.
Yeah, right.
Went from, $200 a share to $100 a share and made it more accessible to the Commonwealth,
right.
So to say. But yeah, I think a person, if they had $1,500 to spend, they could buy one share of Shopify or 100 shares of a $15 stock. And which do you feel better about as an amateur investor?
It's all the same.
Ultimately, it's the same amount of money. Yeah, if it goes from $1,500 to $1,600, it's the same as it going from $15 a share to $16 a share if you own 100 of them. It makes no difference. But I think there's a psychological effect, and it might attract. I don't know if bigger investors tend to buy more expensive stocks. It's a good question. I would think there's probably some psychological effect, but either way, it seems like GE just wanted they said this is just where we feel like we want to be to call in some shares and increase the price. That's going to happen pretty soon.
That's fascinating.
I think they announced the date. But yeah, but a lot of things are happening at GE, like with the CEO, Mr. Culp. They've cut a lot of debt, and it seems like they're going in the right direction. His CEO pay is incredible. Of course, what CEO pay is in it these days, but the GE does seem to be on the up and up. So,
good.
Maybe this is part of a new lease, like a new leaf for them with more press releases, like you said, just trying to be in the news cycle more, that they're really actively trying to be a world leader, which of course every company is. So. Last on the docket today, and this is a really interesting piece of engineering, kind of goes, not really hand in hand with what Cobot's doing, but just the idea of how can you get wind turbines taller. And this company, Esteco, has built a telescopic concrete tower. It was just finished in China, their first prototype, and it's in full operation now. And basically, this technology that they patented is kind of like these self-building cranes. So Alan and I were talking off camera that, in DC, there's cranes everywhere. They're always building new construction. You see these things, and I remember one day recently I was looking, I'm like, how did that crane come to exist like in this city? And apparently they build themselves. So they start off as like a 30 or 40 foot crane, and they have these like lattice work sections, and they pull up another, maybe like 20 meter section, and it hoists it into place, and then they bolt it in, and then the crane crawls up it, and then it hoists another section, puts it into place, it crawls up it, and then it just keeps going until it's assembled itself, essentially. I'll put a link in the description so you can see that on YouTube. There's some really good examples, because people YouTube this question like I did. How do these things exist? Is there like a master crane somewhere? But essentially, in this press release from Esteco, they said they're kind of following the same concept where they assemble a section, they go up, and then cast the next concrete section above it, and keep going up as the sections get a little bit more narrow in a telescoping kind of way. But this tower looks really impressive, and they said it's in operation in China. So, Alan, do you feel like this is something that? I mean, it feels like this is a why didn't this exist earlier kind of technology. It doesn't seem super high tech or super. Was it just hiding in plain sight the whole time?
I think it's kind of like Cobot in a sense that 3D printing of concrete is a logical extension of 3D printing of plastics. But there's a lot of problems you have to solve in order to go make that happen. And I'm betting this is the same thing. Obviously, getting the wind turbine higher up in the air gets it into cleaner air and more velocity air typically. That's why the scale of wind turbines has grown so massively over the last couple of years. Intercept more wind, create more power. Get in the right wind space, make more power. The question is, it becomes an economic issue of, do I make a taller steel tower? Do I need a bigger crane to assemble this thing? Which is what you would need, right? You need another crane to lift this thing up higher, and the cranes are already expensive the way that they are, versus making something that's sort of erector set, builds itself. Stackable concrete sections, or you're pouring concrete sections and lifting it and then put another one in. That's a very fascinating way of doing it. And, you know, in these engineering type events where you're breaking ground on a construction technique, that takes a long time to penetrate. It just does, right? How long have we known how to build houses out of concrete and haven't? But all of a sudden now we're back at it again. I think Thomas Edison was building houses out of concrete back in the late 1800s, early 1900s. And here we are in 2021, and now we're going at it again. It takes a long time to gain acceptance and figure out all the bugs and to get something that's a prototype-ish functional enough that you can then see what the revenue is created by this thing. And if the revenue created by creating these concrete towers generates more electricity and costs less to do than a steel tube, then the industry will change. And I think companies like Cobot are kind of set up for that, right? I think you're going to see concrete built wind turbine structures going to grow massively, particularly in the United States, because they figured it out. So this is going to be, you know, when you see things in China happen, construction-wise, from an engineering standpoint, you go, okay, safety. Has all the safety things been in place to go do this? Could you do that same thing in the United States or in Europe? Or there's safety things that are happening during that construction that would not be tolerated by code? Maybe. Because you think the GEs and the Siemens, Gamesas of the world and Vestises of the world will have seen this and go, oh, that's cool. Maybe we need to do that.
Yeah. And so this tower that they built, this turbine, is 170 meter hub height. So, 500, 35 feet, something like that. I don't know if my meter math is exactly accurate to feet, but it's really tall, obviously. And it's not exactly clear. I wish they had a video of how this process worked. I scoured the internet to try to find it. Couldn't find it, but it says they cast them in place on the ground level. I just want to clarify my earlier statements, but then it says by means of a climbing formwork. So I don't exactly know what that means. But I'd love to see a video of this in the future. We'll see if they release something on the web, because it seems like a really interesting process, but then they're just arranged on, one side on top of the other. So, yeah, I mean, and I'm curious if concrete is more expensive than steel, especially for that height. I'm not sure.
Depends.
Obviously, there's going to be a lot of rebar inside of it, and there's a lot of technical challenges rather than just assembling pre-built chunks of
the steel
tower,
right? The issue with steel is transportation, where it's not an issue with liquid concrete.
Yeah, they're going to cast it.
Right, so you can drive the truck up there,
which is nice.
Pump it up, right, instead of trying to haul this big, massive steel structure up there.
And this just it seems like another step of, if you 3D print the base, which Cobot is doing, you then cast on site the tower, which this company is doing, and then potentially 3D print the blades, right, which Orbital Composites wants to do in the near future. You have the whole thing made
on site
locally by local workers using local materials, hopefully with, shredded. And that's the other thing here is concrete tower. You could have a lot of shredded wind turbine blades in that concrete mix, which is pretty cool. That would be a great use for it. Yeah.
Well, as we get to the offshore explosion that's about to happen in the United States, I really wonder if some of that 3D technology is going to be implemented, just because a lot of it's developed in the United States. Some of it is. But if you're going to start fresh now with a new factory and would you do what we did in the 1980s? Or do you say, we're going to take a new approach that's less cost intensive to manufacture blades and manufacture bases and the whole thing? Because you kind of start fresh sheet all of a sudden, particularly on offshore, because there's not especially when we get to floating, there's not a lot of history there, so everything is up for grabs, and that's when you tend to see those little technology leaps happen, because clean sheet allows engineers to be creative and to do things that they wouldn't have done 10 years ago. So it's going to be quite a ride coming up.
Well, that's it for today's episode of the Uptime Podcast. Thanks so much for listening. Be sure to subscribe to the show, share with a friend, and don't forget Uptime Tech News, our Thursday morning newsletter just with new updates on the show, new tech around the wind industry is in the show notes, whether you're on YouTube, iTunes, Spotify. So you can click below, sign up for that, and get an update for us every time we release a new episode. So thanks again for listening, and we will see you here next time on the Uptime Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.